Okay, quick updates on manufacturing in space. We've talked about these before. There's been a lot of research going on in the last couple of years on the space station for figuring out what can you make in space that works better and would be actually competitive with products on Earth. So some of these products actually have come back on the most recent Cargo Dragon return from the space station. One was printed living cardiac tissue. This is bioprinted. Think of 3D printing except with cells. They would use that for repairing hearts, and so they're going to evaluate it. But their next goals, they're going to be doing blood vessels, and eventually they want to do entire organs. But the key thing is they think they can actually do this in space. Without the gravity being there, you can make the structures a lot better without things falling apart. And they've apparently concluded that it really is more effective in space. They're also doing a bunch of research sponsored by Eli Lilly. They brought back 36 different experiments for making drugs. Everybody's looking for the killer app. What can we do in space that we can't do that well on Earth? And they're still struggling, but we're getting a lot closer. I think these kind of things are encouraging. In some ways, the most encouraging is this one, optical fiber. Now, there's various ways to make optical fiber for communications networks and so on. The ones on Earth mostly are made from sand or silica. But there's one called Z-bland. That's an acronym that stands for a whole bunch of other elements that are used. But it's actually a factor of 10 to 100 absorbing less light. As a result, you don't need so many repeater stations. For instance, if you're doing undersea communications under the ocean, you have to have repeaters pretty often to take the incoming signal because it's been attenuated by the non-clarity of the fiber, and re-amplify it and then shoot it on to the next one. If you can avoid all that, it can make a huge difference. Also, apparently, there's some laser applications that are more immediate. So the reason it's better is that there are a lot fewer imperfections when you manufacture it up there than there are on Earth. That's the competitive advantage of space in this case, fewer imperfections. This stuff sells for $1,000 a meter.
$1,000 a yard, geez.
Yeah, $1,000 a yard. That's the first time they've really done commercial quantities here. That set some records. They made 8 kilometers of this cable up there. And the longest single length was 1 kilometer. This is approaching something you can actually sell, kind of an industrial scale. They made a daily record of a half a mile of fiber in one day. So this is a big step forward for manufacturing in space.
Doug Hall asked how automated these experiments were, considering the limited astronaut time available.
In most of them, they tried to make them as automated as possible. That's kind of the goal. There's way too much human intervention involved in all this stuff with the space station. The space station is a wonderful lab environment, but like any other manufacturing situation, once you prove it in the lab, you do your manufacturing somewhere else. They'll probably do it in something like the Varda industry stuff that we've talked about before, where they just send up their own separate craft, and then they just bring it back down when it's done, and they don't bother the station. But the space station is playing a very important role in this kind of research, is figuring out what you can make. They're all small scale, but they're proving out the processes. This particular one, their first testing was done in the Vomit Comet. The plane that gives you 2 or 3 minutes of weightlessness, they would actually get up there and everybody all ready to go the second, and they were doing little experiments, even in that 2 or 3 minutes. They do that kind of study first, and they said, okay, now let's try it on the space station where it's always weightless. So there's a process you go through to do this.
Doug wondered about vibrations affecting the experiments. Astronauts bounce around, equipment starts and stops, and so on.
Yeah, I don't know how they dealt with it in this case. Maybe it just wasn't so much of an issue for them. Some of the others they've talked about just running them separately outside the space station, and avoiding that. The vibrations are a definite problem. So thinking about it, when will you finally succeed in manufacturing in space? Well, you have to have a couple of key things. One is it has to be very expensive stuff, just to justify the efforts of getting up there and getting back. That's huge. So that costs a lot. But in this case, if you can sell $1,000 a meter, and they had 8 kilometers of the stuff, they've already paid for that mission. And the other thing is, there are some things that you can probably make better in space. Typically, it's things like crystals. They can grow, they don't get pulled down by gravity. So things like microgravity are important, maybe the vacuum conditions, maybe the low temperature if you do it outside. Longer term, we ought to be manufacturing solar cells with lunar materials. There's a couple bottlenecks in all this. The biggest one is downmass, getting back to Earth. And that's the problem with the space station right now, is that there aren't that many ways to bring anything back from space right now.
Varda and SpaceForge are 2 companies offering solutions to this problem. We covered them in detail back in November 2023. Both companies will manufacture using their own satellites. They have found inexpensive ways to land the satellites with their products and then reuse the satellite. The bottom row of the slide shows the satellites and landing for Varda. The top row shows the satellite and landing for SpaceForge. Their heat shield is huge, so they don't need a parachute or a conventional heat shield like Varda.
The other capability is going to be inflatable heat shields. NASA's working on that.
Also, the Sierra Space Dream Chaser spaceplane should be launching this year for servicing the space station. It is like a miniature space shuttle with cargo space. Initial versions will be automated and only take cargo up and down.
I used to think, oh, you'll never be manufacturing stuff in space for use on Earth. But it turns out that probably will be doing it.
Other space-related videos or slide presentations by me are available at the link shown here. That includes a list of videos at my YouTube channel, so you can view them or subscribe for notifications about future videos. These presentations are mostly made as part of the meetings of National Space Society's North Houston chapter, and the link to that is shown. Topics like these are presented as part of a monthly news segment, and there are also lots of other interesting speakers and open discussions. You can attend in person or online via Zoom. Come join us.